In last few videos, you have already got a good sense of how assembly language works. Now let's take this one step further and let's see how you could write more complex programs in a high level programming language such as C. If you haven't already installed the C compiler on your machine, I recommend that you do that now. Please read the description below for details. So let's start writing our first C program. I'm gonna say this is my first C program. So in C, when you start a line with two slashes, the compiler will ignore anything after that. And these are called comments. So just like assembly language, even C programs can get confusing at times. And especially when there is more than one person working on it. So it is always good to add some comments to your code so that when you look at the same code after 1 year, or let's say if someone else is looking at your code, they can understand it as well. So now we are going to say hash include stdio.h. In C, the lines which starts with the hash or the pound sign are special. So these are not the instructions for your machine, but these are the instructions for your compiler. And what we are telling the compiler over here is take this file stdio.h and paste it over here. Stdio is the standard IO. IO is input and output. And it has the functions like the printf and the scanf that we are going to see further. So the next thing that we want to do is write our actual program, and that we do inside the main function. So we are going to say int main and then brackets, and then we are going to have a pair of curly brackets. So C is one of those languages which uses curly brackets to group things together. So essentially what we are saying to compiler is everything that is within these curly brackets is part of the main function. Makes sense, right? So just like we saw before, let's print something out to the screen. And if you remember, the name of the function was something called as printf. So let's say something like I have %d number of apples, and then we're gonna say 8. So what we are telling the compiler to do is take whatever number is over here and put it inside this sentence, the place where we have this %d, which means an integer. And because we said that this is an int main, which means we are gonna return an integer, and as we promised, let's return an integer to the operating system. So you could return any number from here, and it's up to the operating system to decide what to do with it. But the normal convention is to return a 0 for a successful execution, or 1 or even higher numbers to indicate some failure. So now let's run this and see if it works.
So let's try to compile this, and to do that we'll say gcc, which is the name of our compiler. We'll say -wall. Now I'm not gonna tell you what that means. I want you to look that up on internet and find out for yourself. Remember, one of the goals of this course is to make you a good problem solver, and to do that you need to have some research skills as well. So I want you to think like a scientist and not just take whatever I say. So go to the internet and find out why am I using -wall, and maybe you can share that with your other friends in the comments below. And then we'll have the name of the file, which is hello.c, and then we'll say the name of the output by using -o. The name of the output file we want is hello. So that compiles without any error. Let's try to run this, and you can run it by using /hello. There it is. It says I have 8 number of apples.
But this is a boring program, right? I mean, there isn't much useful that we can do with it. What if the number of apples that I have change every day? What if someone gives me new apples? So instead of directly printing it out over here, let's create an integer which will store the number of apples that we have, and then we'll print that out. So what should we call it? Let's call it num apples. Int num apples is 8. Now instead of writing 8 over here directly, I could say num apples. So this is similar to what we did in the machine code, right? When we had to put a number inside a memory, and this is what we are doing over here as well. So let's see if this works. So we are gonna compile it again, and then we are gonna run it. So as you see, we got the same result, but this time instead we are storing this number in a memory somewhere. So let's do more interesting stuff with our program. So let's say if someone took one of the apples that I had. So let's see how we can say that to our program. So should we say something like int numapples equals to int numapples minus 1. So let's see if that works, right? So we'll compile the program once again. Oops, what does it say? It says redefinition of numapples. So it is telling us that you have already told me what numapples is. It's an integer. So now every time you want to use numapples, don't give me the int once again, right? So what we should have done instead is just say numapples equals to numapples minus 1. Now let's see if that works. We'll save it and then let's see if that works. We didn't get any red flags, so that's a good sign. Let's see if that works correctly. And there it is. It says I have 7 number of apples, which is what you would expect if I had 8 and someone took 1 away from me. So this is good, but still not that interesting, right? What if we want the users to tell us how many apples they have and then print it out on screen? So let's try doing that. So we'll first get rid of this line which we had over here. So instead of saying int numapples equals to 8, we'll just say int numapples because we don't know how many apples the user has. So let's first ask the user to tell us how many apples do you have, and then we are gonna say scanf. So printf is used to print to the screen, but a scanf can take the user input and store it in our program. So we are gonna say scan an integer for us, right, and store it in numapples. So now let's see if this works. We're just gonna clear our screen. Then we're gonna say compile it once again. So we did get a few warnings, but let's leave that for now as it is. So there were no errors. So it's asking us how many apples do you have. So let's say I say 10, and gives us something called a segmentation fault. So whenever you get a segmentation fault, remember that your computer is trying to tell you that you are either reading or writing from a memory location which you are not allowed to. And it makes sense for the operating system to do that, right? What if your program was modifying something in someone else's program's memory? I mean, it would be a chaos, and that's why it can't allow you to do that. So what went wrong? So let's see if our warnings can give us some hint. So in the first warning over here, it is telling us that something is wrong with numapples in the scanf line, right? So what we want this line to do is to take the user input and put it at a location which we are calling numapples. But do we actually know what numapples is equal to right now? We don't know, right? It could be any garbage value that the compiler chooses to come up with. So let's say if numapples had the value xyz in it, what's happening right now is the computer is trying to write to the location xyz instead of the numapples, which is actually the value of numapples right now. And this might be a little bit confusing to you right now, but you will get a knack of it once we go ahead. So instead of saying numapples over here, what we want the compiler to do is actually store at the address of numapples. And the way you call address in C program is to write an ampersand. So we say scanf, take the user input and put it at the address which we are calling it as numapples. So let's see if that works. So we compile it once again and let's run it. How many apples do you have? Let's say 20. And there it is. It says I have 20 apples.